Rational numbers. Natural numbers, whole numbers, and integers don't contain any fractions or decimals. But of course, fractions and decimals are still perfectly valid numbers, so they have to be in a different set of numbers. We call this set the rational numbers, Q. And it's not R for another reason. You'll see we'll find another set of numbers a little later which gets an R. So rational numbers are any numbers that can be written as a fraction, like P over Q, where P and Q are integers and Q does not equal 0. Because of course you can't have 0 on the bottom of a fraction. Now, by that definition, all the natural numbers, all the whole numbers, and integers are rational numbers. We can write all those as a fraction. For example, 4, which is a natural number, a whole number, and an integer, we can write as 4 over 1. So that's a rational number. Same goes with 0. 0 can be 0 over 1, or even 0 over 2. And similarly, if we had something that was just an integer, like negative 11, we could just write that as negative 11 over 1, or 11 over negative 1. So all of these are rational numbers because you can write them as fractions where the top and bottom of the fraction, numerator and denominator, are just integers. So where do decimals fit into this? Well, decimals are just fractions in disguise, but not necessarily all of them. So let's go into this. Any decimal that terminates can be written as a fraction. So terminates just means ends. So for example, 0.25, that's equal to a quarter. So 0.25 is a rational number. Here's another example, negative 3.15. That's a decimal number, and because the decimal just terminates, it is going to be a rational number. And if we wanted to, we could write this as a fraction. We could write it as negative 315 over 100. That's not a skill we're going to focus on in this course, but it is something that you can do with any decimal number. And if we wanted to simplify that, we could get negative 63 over 20. That'd be the most simple that fraction can get. Now, how about the decimal form of 1/3? You'll probably remember from previous classes, or if you just stick it in your calculator, when you do 1 divided by 3, you get 0.3333, and on and on and on. Or another way to write that is 0.3 with a bar above the 3, and that means that it's repeating forever. So these decimals that keep repeating on and on, if they can be written as a fraction, well then that means they're rational numbers too. So any repeating decimal can be written as a fraction, and therefore it's a rational number. So let's go through some examples. Which of these are rational numbers? Well, 0.6666 repeating. It doesn't matter if you have 3 repeating, it just means that the 6s are repeating on and on. That's rational. And if we wanted, we could write it as a fraction. That's 2 over 3. The next one, 0.652652, dot, dot, dot means it's going on and on and on. Well, we can see repetition, 652, 652. So this is also rational because the decimal is repeating. And in fact, this is a cool trick about nines. We can write this as a fraction as 652 divided by 999. Try that in your calculator and you'll see that it's true. Going on to part C, it looks like there's a little repetition here. We have 1, and then 1, 2, and then 1, 2, 3, and 1, 2, 3, 4. But this is not rational because the repetition has to be the same thing. It can't just be a pattern that's going on and on. It has to be the exact same thing repeating over and over and over again. So this is not rational. 1, 2, 3, 4, 5 with a bar over top though, that is rational because that's repeating forever. And again, we could actually write this as a fraction 1, 2, 3, 4, 5 over 99999. Finally, the last one we see, 3.141592, you might recognize that's the digits of pi. And there's no repetition going on, there's no pattern. That's not rational. So pi is not a rational number because its decimals keep going on forever without ever repeating at all. The last thing to mention is that a number that's written as a fraction might still be a natural whole number or integer. It's just that we need to simplify to see if that's true. So for example, 9 over 3 is just equal to 3. So that number is rational. It's an integer. It's whole. And it's natural. It belongs to all of the sets we've talked about so far. Negative 144 divided by 12 is equal to negative 12. So this one would be rational, and it would also be an integer. Lastly, negative 61 divided by 2, well, that's equal to positive 31. So even though there was negatives in the fraction, it actually is still rational, an integer, whole, and natural. So just because there was negatives in the original fraction, because it simplifies to positive 31, that makes it a natural number.